video lecture series of Grade 10 Physics. Today I am going to discuss the lesson Electricity, and the topic is a combination of series and parallel resistors. In the previous videos we already discussed about series connection and parallel connection. In some connections there will be a combination of series as well as parallel connection. So how can we calculate the resistance in such connections? So let us solve one by one. Look at the diagram given here. Here they are asking to calculate the total resistance of the circuit in the following diagram. So when you look at this diagram, you can see there are four resistors connected in the circuit. So R1 is the first one, then R2, R3 and R4. There are four resistors connected over here. So how do we know that which one is parallel and which one is series? We can easily solve this problem by stretching the two ends of the circuit. This is the one end of the circuit, okay? We can name it as A. The second end is B. So when you stretch these two ends, the connection will be in this way. So which means that these two resistors are in series now. So I have stretched R3 and R4. Okay, so we have got two series connections. Similarly, the other side, that is R1 and R2, will be coming in this way. This is R1 and R2. When you stretch both the ends of the circuit, R1 and R2 become series connection and R3 and R4 becomes series connection. Now, you can calculate separately R1 and R2 by calculating the total resistance in series connection. Similarly, you can calculate R3 and R4, the total resistance of R3 and R4. So, R1 and R2 are in series connection. So, RS1, I am writing here RS1. So, RS1 is the series connection, the first series connection, that is R1 and R2. It's a combination of R1 and R2. So R1 is given as the resistance 2 ohm and R2 is 3 ohm and R2 is 3 ohm. Now when you add these two, you will get it as 5 ohms. Now the second series connection RS2 is equal to, it's a combination of R3 and R4. So R3 is equal to 1 ohm and R4 is equal to 4 ohms. So when you add, you will get it as 5 ohms. So the two series connections, you got it as 5 ohm and 5 ohms. Now these two resistors RS1 and RS2, now we have to consider as parallel connection. One is parallel to the other. We calculated the total resistance in R1 and R2. Similarly, we calculated the total resistance of R3 and R4. So now both the connection we can consider as parallel connections. Now it is coming in this way. So this is RS1 and one is RS2. So RS1 and RS2. RS1 is 5 ohm and RS2 is 5 ohms. So what is the equation for parallel connection? The effective resistance in the parallel connection is equal to 1 by Rp is equal to 1 by RS1 plus 1 by RS2. Which means 1 by RS1 is 5 ohms. So 1 by 5 plus 1 by 5, which is equal to 2 by 5. This is for 1 by Rp. Therefore, Rp is equal to 5 by 2. 5 by 2 means it is half of 5, that is 2.5 ohms. Okay, children. Now we can solve the second problem as it is given in this way. We have 6 resistors and 3 resistors are connected in series, and the next 3 resistors are connected in another series connection. Now you can take it as the way which we have solved the previous one. This you can take it as RS1. These 3 resistors are in series connection, and consider the other 3 as RS2. Okay. Now RS1 is the combination of the 3 resistors, 2 ohm, 3 ohm and 5 ohm. So that you can add together 2 plus 3 plus 5, you will get it as 10 ohms. Now what is RS2? RS2 is the combination of 1 ohm, 4 ohm and 5 ohm. So 1 plus 4 plus 5, which is equal to again 10 ohms. So now you have to consider the total resistance RS1 and RS2 as parallel combination. How do we solve that one? 1 by Rp is equal to 1 by Rp is equal to 1 by Rs1 plus 1 by Rs2. Now 1 by Rs1 is 1 by 10, 1 by Rs2 is again 1 by 10, which means it is equal to 2 by 10. Now therefore Rp is equal to 10 by 2, which is equal to 5 ohms. Next we can solve one more question. In this connection, it's given 5 resistors. The first 2 are in parallel connection and the next 3 are again in parallel connection. So the first 2, so this we can consider R1 and this is R2, then R3, this is R4 and this one is R5. So total there are 5 resistors. Now if we consider R1 and R2, these 2 are in parallel combination. So what is the effective resistance for that? 1 by Rp1 is equal to 1 by R1 plus 1 by R2. What is R1? R1 is 5 ohm. So 1 by 5 plus what is R2? It is 20 ohm. So 1 by 5 plus 1 by 20. When you take LCM, you will get it as 20. So 20 into 4 plus 1. You can calculate in this way, 20 into 1 by 5. So it will get 4. So 4 plus 20 into 1 by 20. So you can solve it as 1. So 4 plus 1, that is 5 by 20. 5 by 20 means which is 1 by 4. Therefore Rp1 is equal to 4 ohms. Now we have calculated the first total resistance for Rp1. Now take the second connection. In second connection we have 3 resistors R3, R4 and R5. These 3 are in parallel to each other. That we can solve in this way. 1 divided by Rp2, 1 by Rp2. So this is Rp1. The second connection is this, that is Rp2. So 1 by Rp2 is equal to, there are 3 resistors R3, R4 and R5. So 1 by R3 plus 1 by R4 plus 1 by R5. So what is R3? R3 is 2 ohms. It's given 2 ohms plus 1 by R4. What is R4? That is 3 ohm. What is R5? R5 is 6 ohms. So 1 by 6 ohm. And when you take LCM, it will be 6. So 6 into 1 by 2. So we'll get it as 3. 3 plus 6 into 1 by 3. That is 2. 2 plus 6 into 1 by 6. That will be taken as 1. So 3 plus 2 plus 1. Total it is 6 by 6, which is equal to 1. So 1 by Rp2 is 1. So therefore Rp2 is equal to 1. Okay. So we have got Rp1 as 4 ohm. Rp1 as 4 ohm and Rp2 as 1 ohm. Then these two parallel connections we need to consider as series connection. How do we solve it again? Now 1 by Rp1 and 1 by Rp2 you can consider as series connection. So this is 1 by Rp1. We calculated it as 4 ohms. Now the second connection we calculated 1 by Rp2. This is 1 by Rp2. That is 1 ohm. Both you can now consider as a series connection. Now what is the equation for series connection? Rs is equal to total resistance in series connection. Rs is equal to Rp1 plus Rp2. So 4 plus 1, which is equal to 5 ohms. Okay children. Now we'll solve one more problem. In this connection it is given 3 resistors. Okay. Here we are going to calculate 3 questions. The questions are, first of all I am just calculating total resistance. Total resistance of the circuit. Second I am going to calculate total current flowing through the circuit. Total current flowing through the circuit. Third one, potential difference across PD. Potential difference across R1. Okay. So there are 3 resistors, R1 and this is R2 and the third one is R3. So R1 is given as 8 ohms and R2 is 12 ohms and R3 is 7.2 ohms. So first of all we can calculate the total resistance of parallel connection. These two connection R1 and R2 in parallel connection. So total resistance in parallel connection 1 by Rp is equal to 1 by R1 plus 1 by R2. Okay, so 1 by 8, R1 is 8 and R2 is 12. So 1 by 8 plus 1 by 12. Okay, by taking LCM, you will get LCM as 24. So 24 into 1 by 8. That will be 3 plus 24 into 1 by 12. That is 2. So 3 plus 2, which is equal to 5 by 24. Therefore, Rp is equal to 24 by 5, which is equal to, when you saw, it will be equal to nearly 4.8 ohms. Now, we have a series connection now. So this one is R3. Now we have calculated these two parallel connections effective resistance, and that you have got as 4.8 ohms. Now consider this is R3, and the total resistance from the parallel connection you got it as 4.8 ohms. So this is the total resistance for the parallel connection. That is, we can now consider as, I'm just considering as this is RP1, or you can simply consider as RP. So R3 is equal to 7.2 and this one is 4.8. This is the total resistance which we calculated for the parallel connection. Therefore, total resistance in series connection, these two are in series, so we can calculate the total resistance in series connection. Rs is equal to R3 plus Rp. Okay, that is equal to 7.2 plus 4.8 ohms. It is equal to 8.8 plus 2, that is 10, 7 plus 4, that's 11, 11 plus 1, that is 12, so 12 ohms. So this is the total resistance of the circuit, 12 ohms. Now look at the second question. We have to calculate the total current in the circuit. So according to Ohm's law, you already know, you already studied, current I is equal to V by R. So total current I equals V by R V is equal to 6, or we have calculated as 12 ohm. Potential difference already given in the circuit diagram. It is 6 volt. This is V. Okay, that we have applied in this equation. V is equal to 6 by 12. I mean I is equal to 6 by 12. So we will get it as 1 by 2. 1 by 2 means 0.5 ampere. Now the third question is, we have to calculate the potential difference across R3. Now potential difference, we have the relation V is equal to I into R. I right now we have calculated it as 0.5 ampere at resistance, that is in the third R3. R3 is equal to 7.2 ohms. So 0.5 into 7.2, which is equal to 3.6 volts.